One of the most exciting new discoveries in the field of robotics, which is undergoing consistent and rapid transformation, is called Swarm Robotics. This approach, which has the potential to transform many different industries such as agriculture and disaster assistance, as it involves coordinating a large number of extremely basic robots or agents in order to achieve a common goal. To get to the bottom of things though, what exactly is Swarm Robotics? And is it actually as successful and effective as its proponents say it is? Or are there risks and constraints that aren't being acknowledged? Well, let's get started. Swarm Robotics is a relatively new field that derives its inspiration from the cooperative behaviors of social insects such as bees and ants. In the natural world, these insects work together to accomplish tough tasks such as building nests or finding food. This behavior has long been of interest to academics, and they have spent a great deal of time attempting to replicate it in robotic systems. One of the most exciting aspects of Swarm Robotics is its capacity to finish tasks that a single robot would find difficult or impossible to do. This capability allows Swarm Robotics to perform activities that would be difficult or impossible for a single robot. While working together, these robots are capable of doing tasks that no one agent could ever hope to accomplish on their own. Scalability is another advantage offered by Swarm robots. By utilizing a huge number of agents with the bare minimum of capabilities, systems are founded on the concept of Swarm Robotics have the ability to be scaled up or down depending on the requirements of the task at hand. Because of this, the system is particularly useful in situations that call for a high number of robots, such as those involving emergency response to natural disasters. So, do Swarm Robotics have actual real-life applications? Well, Swarm Robotics is essential for search and rescue operations after a natural disaster because they have the potential to save a significant number of lives. In these kinds of emergencies, it could be difficult for human rescue workers to locate and save victims as they make their way through dangerous debris, rubble, and other hazards. Swarm Robotics is able to lend a hand in carrying out an effective search of the area by dispersing a large number of small robots that are capable of maneuvering in confined spaces, scaling obstacles, and exchanging information with one another. And how can they do this, you ask? Swarm Robotics systems may be outfitted with a wide variety of sensors, cameras, and other instruments to aid in the search and localization of surviving individuals. These robots can either operate on their own or be controlled by a human operator, according to the requirements of the situation. Swarm Robotics can also minimize the risk to human workers since the robots can access dangerous regions that are too dangerous for people to enter. This makes it possible for robots to save more lives. And even if there are problems that need to be worked out, such as keeping appropriate communication and coordination among the swarm, the future of this use of the technology looks promising. And that's not all. Underground mining is a dangerous and challenging occupation that usually demands miners to walk through confined tunnels and gather resources under deadly circumstances. Because of this, underground mining is considered one of the most dangerous jobs in the world. But now, Swarm Robotics is able to automate these processes by deploying a fleet of cooperative robots. And as time goes by, human miners will no longer be required to work in potentially dangerous environments. It is possible that the application of swarm robots might increase productivity in the mining industry. By employing a swarm of parallel working robots, it is possible to harvest resources faster and more efficiently than with traditional mining techniques. Robots may also be programmed to work non-stop, eliminating the need for breaks and boosting the mining operations' overall productivity. Simply, the application of swarm robots in mining might, on the whole, result in an increase in production while simultaneously lowering costs and raising the levels of both efficiency and safety. Swarm robots have demonstrated significant potential in a variety of fields, including the military. The use of small, agile robots capable of working together to aid human troops on the ground can significantly improve the security and efficiency of military operations. Swarm robotics, for instance, might be used in combat scenarios for reconnaissance by deploying a swarm of drones that can gather information on the positions and movement of the adversary. These drones are equipped with cameras or sensors that may detect heat signatures and other indicators of aggressive behavior. Swarm robotics can be utilized for communication purposes if it is first constructed in the form of a network of drones that can provide a secure and trustworthy mode of communication amongst ground troops. Swarm robotics has the potential to be used for offensive purposes, which requires a swarm of drones capable of launching precision strikes on the targets of an enemy. Using swarm robots might considerably improve the efficiency and safety of military operations in general. Swarm Robotics is utilized in some applications for 3D printing. This helps to automate the printing process and increases overall efficiency. Using a digital model as a starting point, a three-dimensional object may be printed via 3D printing by stacking material layers one on top of the other. This process can be time-consuming and expensive, particularly when it is used to create enormous structures. Setting up a swarm of cooperative robots that are capable of building large buildings is one way to cut down on the amount of time and money required for 3D printing. Printing individual components of the product one at a time, these robots are able to perform many tasks simultaneously. This speeds up the process and reduces the amount of human intervention that is required, which ultimately results in an increase in printing efficiency. But what does the future hold for this technology? Well, the study of Swarm Robotics is seeing rapid growth and looks to have a promising future. Due to technological advances, we can now direct even the simplest robots to carry out complex operations under our command. This approach offers a variety of advantages over traditional robotics, including cost-effectiveness, sturdiness, and adaptability, to name a few. Researchers are working hard to improve agent collaboration and communication by developing new algorithms and methodologies, which means the potential application of swarm robots are almost endless. The future of swarm robots can also be explored, which is a possibility. We are now able to explore difficult terrain using swarms of robots, as well as chart new locations rapidly and correctly. It is possible to utilize this technique to investigate hostile parts of the planet, such as the depths of the ocean, the depths of space, or other unfriendly places. Every type of technology raises questions that need to be considered in terms of ethics. As autonomous robots become more sophisticated, we have a responsibility to ensure that they are used appropriately and that there are enough safeguards in place to avoid their inappropriate application. However, the field of swarm robotics is poised for significant growth. Over time, we can probably anticipate seeing an increasing number of applications of this technology across a wide variety of business sectors. So what do you think about swarm robotics? Do you think it's a revolutionary technology?